Greetings to all the participants present here. On behalf of QA Research and Publications, I would like to welcome you all for the webinar on Introduction to Exploratory Factors Analysis in SPSS. To start with, let me give you a brief about QA Research and Publications. QA serves as a platform to publish research articles in prominent journals and conferences proceedings. We assist authors in publishing their research findings in high impact factor journals, promoting their work, enhancing their reputation, and building a strong scientific profile. Among several indexing databases, Scopus is one of the most preferred for publishing articles. The wide recognition and impact of these journals make them highly valued in the academic careers. We have recently collaborated with Scopus Q1 journal called FN1000 Research, published by Taylor and Francis. The authors can now easily submit their articles through a partnered gateway with FN1000. FN1000 Research is an open research publishing platform for scientists, scholars, and clinicians that offers rapid publication of articles and other research outputs without editorial bias. All articles benefits from transparent peer review and editorial guidance on making all source data openly available. Now, I would like to welcome our speaker, Dr. Ling Hinckley, who is an educator at Polytechnic Malaysia, actively engaged in supervising doctoral projects within Malaysia and internationally. Dr. Ling holds a bachelor's degree in guidance and counseling education from University Putra, Malaysia, and a bachelor's degree in information technology education from Sultan Idris Education University. Additionally, Dr. Ling obtained a master's degree in educational management from Sultan Idris Education University. Driven by a passion for advancing research knowledge and writing skill, Dr. Ling successfully earned a doctoral degree in educational leadership and management from University Sains Malaysia. Continuously dedicated to mentoring postgraduate students in research, Dr. Ling plays an active role as a panelist, judge, and reviewer in various seminars and training sessions at multiple levels. To date, Dr. Ling remains actively involved in diverse writing, endeavors, and presentations. Once again, I would like to welcome you, Doctor. You may start now.
Okay, many thanks to the organizer once again for inviting me to be the speaker on this online webinar, the webinar for the statistics especially. And thanks so much for all the participants to join this workshop. So this is the webinar on the title Introduction to Exploratory Factor Analysis. Okay, so is it clear? Yeah. Can you hear me, everyone?
Yes, doctor, we can hear you.
All right,
Loud and
thank you. Thank you. Okay, so a little bit tips for all the participants. Based on my experience when I conduct the webinar or any statistic courses to the participants, normally I would like to advise my participants don't rush to understand all the terminology presented because in any courses or training that I organize or I take part to all the participants, normally I will introduce to the participants with a lot of the new terminology, especially for the the beginners researchers. So what you need to do is you try to understand the existence of the new terminology, if any, and relate it to the current studies being conducted. And especially this advice, I think is very good working to all those scholar students, okay, doctorate students, and this will help you to master this presentation better. So first of all, without wasting the time, so let's see. So I'm going to start the factor analysis, but not talking about the factor analysis yet. I would like to share with you all regarding the scale development. Okay. So right now, nowadays, scale development continues to be a very popular issue in social sciences research. Okay, even though under my supervision all the time, I inform my students not to just take the skill developed by someone else in this way, but what you can do is you can try to revise, refine, okay, on this scale. So, mean to say, in other words, developing a reliable and valid scale is really important, especially for those the doctorate students. Skill development refers to a process that entails the clearly defining the target construct, constructing an item pool, testing the pool items on a representative sample, conducting correlation and factor analysis, and examining the dimensions and discrimination validity. Now, again, a little bit about the skill development is the process of creating and validating the measurement scales for the use in the research and assessment. Okay, so especially this one is really useful, the scale, to measure the abstract construct or concepts such as the attitude, belief, behaviors, or personality traits. So developing a scale involves several stages. It's not just give and take like this, but involve really a lot of the professional stages. So including this conceptualization, item generation, scale construction, and validation. So allow me to share with you more details on each stage. So first of all, conceptualization. So for the conceptualization here, this stage involve this stage involve the defining the construct, okay, defining the construct of interest clearly and precisely. So the researchers needs to understand the theoretical foundation of the construct and the operational definition, which specify how the construct will be measured. So I do believe that when you all take a look on this slide, so especially the beginners, then you notice how important actually and why all the supervisors keep asking you to read more to define according to the operational definition on the terms, and also keep asking you to explore more or deeply on the theoretical foundation of the construct. Okay, now the next one is the item generation. So in this stage here, the researchers generate a pool of items that represent the construct being measured. Okay, and these items can be the statements, questions, items, or other similar designed to assess the different facets of the construct. And the goal is to create a comprehensive set of items that capture the various dimensions of the construct. So um, the next one is the scale construction. Once the item pool is generated, researchers select the most relevant and representative item to include in the scale. And how can we get the most relevant and representative item? Exactly through your literature review, through your reading. That's why the researchers really need to read a lot so that you know how to select the good items. And this process often involve reducing the item pool through the techniques such as the expert review, pilot testing. And normally what we are doing now, and I can see from most of my students, what they are doing to ensure that their items is the good one, the quality one, and they involve the reducing the item, they only through the feedback, constructive feedback from the expert review, and also through their pilot testing. But in fact, there is another way, that is what we call as factor analysis. And through this factor analysis, actually, okay, the researchers able to, how to say, able to perform the better scale construction. So the researchers also determine the response format for the scale and also the scoring procedure. And the next one here is validation. And I do believe that we all very familiar with the keywords validation. When we talk about the validation, it's related to the reliability and also the validity. But we have to understand that validation is the very important step in the scale development, ensuring that the scale measures what it is intended to measure accurately and reliably. So talking about validation actually is not only about the reliability and not only about the validity, actually more than that. For those master students, when they want to do the validation, it's okay. Okay, if they just want to conduct with using the validity and reliability to settle this stage of validation, then that is fine. But for the doctorate student, I strongly advise you to go on further. And the next one is the refinement. Okay, after validation, the researchers may refine the scale further based on the feedback from the validation studies or additional research. Okay, and this may involve revising or removing the items, adjusting the response formats, or fine-tuning scoring procedures. Okay, that's why normally when we try to get some the scale for our research, we need to make sure that we don't just adopt it. We need to adapt it. Adapt, and then we go through the process on revising and removing some unsuitable items, and then we adjust the format again. So the next one is norming. Norming involves establishing the norms or reference values for the scale based on a representative sample of the target population. So norms provide the context for interpreting the individual scores and comparing them to the larger population. So when I talk about the norming, sometimes people may confuse. So to make it easy to understand, so normally here, I take one example here, sample selection. Sample selections here, to establish the norms for a scale, we have to make sure that the sample selected that can represent, able to represent the whole population for which the scale is intended. And the sample reflect the demographic characteristic of the population of interest. Other than sample selection, actually, we need to focus also on the administration of the scale, data analysis, and so on. Administration of the scale, that is about how are you going to implement the procedure of data collection and the procedure of data analyzing. So these are all the things involved in this norming stage. So the next one is dissemination. So regarding this dissemination, once the scale is developed and validated, the researchers may publish their findings in academic journals and present them at a conference or make the scale available for the use by other researchers or practitioners. That's why I always inform the students. I say that once you settle your paper, especially for those who done the factor analysis on the scale throughout the scale development, it is your responsibility to share the findings in any of the academic conferences so that people alert on what is the latest findings regarding the scale that you develop. Okay, so no matter how, we need to understand that when we're talking about the skill development, it is often an interactive process. Okay, we repeat and repeat again. The process never ending actually. So with the researchers refining and revising the skill based on the feedback and further research. Okay, for example, last 10 years, okay, when I developed the skill for the feedback environment, so I do believe that when come to these few years, okay, a lot of the new researchers they try to uh they study again on this feedback environment, and then they try to refine again, revise again the scale, okay, based on the latest research findings and the feedback they receive. Okay, so this is how we need to go on. And that's why I say the skill development is considered as an interactive process. So to make sure this interactive process is working and effectively, we need to know how are we going to find the patterns to make sure that this interactive process is going on smoothly. Now, the best way is you need to understand now the factor analysis. But what is factor analysis? It is the statistical method to find the patterns among the observed variables, and it is often used in the social sciences research to determine the quality and validity of a measurement. And so far, I only can say most of the social sciences research, we mostly practice this factor analysis in the research. And other than that, it really depends on the needs of your research. And the primary objective of this factor analysis is to reduce the number of the dimensions according to Brown. And as the Kallinger said, factor analysis is one of the most powerful methods yet for reducing the variable complexity to greater simplicity. Okay. Now, for you to understand better, let's try to see on this slide what is factor analysis again. Okay. So factor analysis examines which underlying factors are measured by a large number of observed variables. And such underlying factors are often variables that are difficult to measure, for example, IQ, depression, and so on. It is very hard for us just to use a single item, single statement to measure IQ or to know how is the depression. Okay, very hard for us to measure just by using a single item. So for measuring this, what we try to do is we write the multiple questions or items that at least partially reflect such factors. So for example, as you can see from here, the numeric IQ here can be measured, let's say, by three different items here, question 1, question 2, and question 3, or item 1, item 2, and item 3. Same to this spatial IQ, the verbal IQ, you cannot find one statement exactly to measure on it. What you have to do is through the review, to the literature review, and you are going to have a lot of different items and able to represent the factors. So now, let's say if the question 1, 2, and 3, for example, for this one, question 1, 2, and 3, we say that able to measure the numeric IQ, then the Pearson correlation among these items should be significant. When I say these three items should be significant means what? Meaning the respondents, okay, meaning the respondents with high numeric IQ will typically score high on all the three questions and reversely. Okay, same to this one. Let's say question 4, 5, and 6. So if the question 4, 5, and 6 able to measure the spatial IQ as well, then meaning to say, in other words, 4, 5, and 6 here, all the three items here, okay, you can see the significance correlation between all these items. So the same reasoning goes to question 4, 5, and 6. In that case, if they rarely measure the same thing, as I mentioned to you just now, they will probably correlate highly to each other. Okay. Now, let's see. This is the correlation matrix, one of the output that I generate from the data I use. Let's say, for example, as you look, you can see from here, question 1, 2, 3, these three questions, right? These three items correlated to each other. Okay, and there are significant correlation between these three items. But what happens if the question 1 and question 4 measuring possibly unrelated traits, therefore will not necessarily correlate to each other? So in this factor model, if this factor model is correct, we could expect the correlation to follow a pattern as shown, okay, as shown here. All right. So now, but what if I don't have the clue, which or even how many factors are represented by the data? Then in this case, ladies and gentlemen, in this case, we will have to ask the software, okay, SPSS, to suggest some model given the correlation matrix. So that is, we will explore the data. Then we call this process as exploratory factor analysis. And the simplest possible explanation of how it works is that the software try to find, okay, the software here um, try to find the groups of variables that are highly intercorrelated to each other. Okay, now to understand better on the factor analysis, okay, we need to know that why we use factor analysis. Normally, we use factor analysis, okay, commonly used in the first one, data reduction. Okay, so factor analysis takes many variables and reduce or summarize them to represent them in a different smaller factor. And those factors are made up of the initial sets of variables. And we also use for the skill development, as I mentioned to you, especially for those doctorate students, okay? Okay, I strongly encourage you to focus on this skill development. And then to evaluate the evaluation of the psychometric quality of the measure, and also the last one, the assessment of the dimensionality of a set of variables. So regardless what purpose, okay, your factor analysis is used in the determination of a small number of factors based on a particular numbers of interrelated quantitative variables. Okay, so see again and again, I mentioned here it's all about the correlation, actually, interrelated quantitative variables. And unlike the variables directly measured, such as the speed, height, weight, and some variables such as egoism, creativity, happiness, okay, comfort. These are all the things that you cannot measure by using the single measurable entity. Speed, we can easily to check. We can check how is the speed, fast or very fast. But the height, let's say, for example, the height, okay, the weight. But when you want to talk about happiness, for example, because recently I'm conducting the research on the happiness. So happiness, you can't get one exactly item to measure the happiness. You need a set of the measurable entities helping you to identify the construct of the happiness. So they are the construct that are derived from the measurement of other directly observable variables. Now, constructs are usually defined as unobservable latent variables, okay, including the motivation, love, hate, care, altruism, anxiety, and so on. So the construct of teaching effectiveness, for example, several variables are used to allow the measurement of such a construct. Usually, the several scale items are used because the construct may include several dimensions. Meaning to say, okay, I share with you with one of the construct that normally we use, teaching effectiveness. Okay, if you're familiar with the scholar Tessana Moran, okay, Tessana Moran, okay, she tries to identify the teaching effectiveness based on three different dimensions. Meaning to say, she doesn't want to just measure the teaching effectiveness by using the single identity. She needs to relate to another three different dimensions. And all these dimensions also measurable by few identities. Okay. So the factor analysis here measure not directly observable construct by measuring several of its underlying dimensions. The identifications of such underlying dimensions that we call as factors actually simplify the understanding and description of complex construct. Okay. Generally, the number of factors is much smaller than the number of measures. So therefore, the expectation is that a factor represents a set of measures. In fact, when we come to the doctorate writing, dissertation writing, I don't really encourage, okay, from my experience, I don't really encourage you all to just conduct the research by identifying a single factor using the single measurement. Okay, it's good actually for you to use the construct that relate to the few different dimensions, and every dimension is also measurable by a group of measurable entities. Okay, this is what I prefer for those under my supervision normally. And from this angle, factors analysis is viewed as a data reduction technique, as it reduces many overlapping variables to a smaller set of factors. And when I'm talking about this one, reduce many overlapping variables to a smaller set of factors, on this one, we can do by using the factor analysis. How? Later I show to you, okay, that reflect the construct of different dimensions of the constructs. Now, there are two different types of factor analysis. As you can see from here, one is the exploratory factor analysis or EFA, and the other one is the complementary factor analysis. Okay, so CFA. But today, of course, our focus here, because we only have 1 hour webinar here, so it's definitely impossible for me to focus on these two at one time. So I focus on EFA first today. So the EFA aims to identify the variables based on their correlation. And CFA, yes, we use CFA after the EFA, meaning to say, if you conduct the EFA, but you don't follow by the CFA, something sounds like incomplete the process. So those who do the EFA, I strongly encourage you to go on to follow up with the CFA, because CFA attempts to confirm the hypothesis and use the path analysis diagrams to represent the variables and factors. And then EFA also tries to uncover the complex pattern by exploring the data sets and testing the prediction. Okay. So what's the difference between these two actually? Okay, very simple. So when EFA is applied to a data set. The method search for the relationship. And we can see the variables with high correlation. Normally, we group them together between the variables to reduce many to a smaller set of composite factors. EFA help us to reduce the number of the items. How? They group the variables with how to say with high correlation to each other, so that you don't have to see the redundant items in your scale development. All right. Now, the final set of composite factors is a result of exploring relationship in the data and reporting the relationship they are found. In other words, to make it simple and easy to understand, just remember that EFA is an exploratory technique that is utilized in research to group many variables, observed variables, into smaller representative factors. And we call these smaller representative factors as the latent factors. But CFA is utilized to test the particular set of relationship based on some theory and to ascertain the data nicely fits the proposed model. So here again and again show to you the difference between the EFA and CFA. So now uh, once we understand the EFA, before we try to run out the CFA by using the SPSS, we need to understand the assumption. Okay, so that's why you as the researcher, you need to go to join a lot of the courses. Okay, organize. Okay, like these kinds of webinar, or no matter how, you need to practice to understand all these keywords. For example, the first assumption here is that you have to make sure that the EFA no outliers. When you say no outliers, means that there are no such extreme values present in the data set. Okay, SPSS able to help to identify the extreme values, and we have to be very careful on all these extreme values. All right. And I noticed nowadays a lot of the young researchers, they just collect the data and then just use the data without checking on the outlier. That is something very wrong. So for all the doctorate students, we don't make sure we don't do this kind of mistake. All right. The second assumption is adequate sample size. Okay. You want to practice to run the EFA, you have to make sure that you need a group and enough sample size to run the EFA. And then no perfect multicollinearity. Okay, multicollinearity occurs when there are strong correlation among the independent variable. So multicollinearity can amplify the impact of measurement error in factor analysis. When there is high correlation between the predictors, measurement errors is in one variable can spill over to another variable, causing distorted factor loadings and weaken the associations. Because why? Sometimes people say when the variables all with high correlation to each other, right? Sounds like they are measuring the same thing. So that is not good actually. All right. That's why how to solve these kinds of problems, the best action is read more on the journal paper, read more on your literature review to understand every single construct that you use. Homoscedasticity. So these keywords refer to the homogeneity of variance. And since factor analysis is a linear function of measured variable, it does not require the homoscedasticity between the variables. Linearity factors analysis is also based on linearity assumption, and non-linearity variables we also can use them. Just transfer it, however, it change into the linear variable. Interval data. You want to run the EFA, make sure you use the interval data. All right. Now, running the factor analysis in SPSS here, as you can see. So to navigate it, we start from this one. The first one from the menu bar here. Okay, we see the analyze. Click on the analyze here. Okay, we check for this dimension reduction. From this dimension reduction, then we click on the factor. Okay, this simple three step helping you bring you go for the factor analysis in SPSS. But when you're moving, a lot of things that you still need to develop, a lot of things that you need to explore. For example, this one. As you can see here, this one, this is the dialog box appear. Dialog box appear when you click on the factor, this one. After you click the step number 3 factor, this is the first dialog box you see. And the variables here for you to transfer or move all the variables that you want to do under the factor analysis. And then you can see few buttons here, and these few buttons is very important. Descriptive button, extraction button, rotation button, scores, options. Okay, once you click the extraction button, I label as A here. Okay, now you refer to this one. This dialog box refer to A. A here, this one, okay, you will see the under the analyze here, correlation matrix, covariance matrix. And of course, you need to understand what is the difference between the correlation and covariance matrix. And then display unrotated factor solution, script plot, and then the extract here based on the eigenvalues greater than 1, y number 1. You all need to understand this one, y number 1. So if you go for B, descriptive, this is B, the dialog for B, descriptive. Univariate descriptive, initial solution, coefficient, significant levels, determinant, inverse, reproduce, anti-image. And then if you click C, the rotation button show you a lot of the different rotation method. None, Barry-Max, which is a very common rotation method. Most of the researchers, when they run this factor analysis, normally they will choose Barry-Max. But of course, you still need to understand what is the direct oblique mean, Quantimax, Equalmax, Promax. And then under the display here, rotated solution, and of course, this one, loading blocks. And then go for D options here. You can see this one, missing value, exclude cases listwise, exclude cases pairwise, sorted by size, suppress small coefficient, and why I put 0.3. Later, I will show you one by one. Okay. Now, let's go to the basic terminologies in factor analysis. So these terms that you are going to see mostly in the output. Once we generate the output, the data in the factor analysis, the output that we generated will display to you all these terms. So you need to understand all these terms so that easily for you to do the interpretation in your writing. First, Kaiser-Meyer-Oaking. Okay, Kaiser-Meyer-Oaking measure of sampling adequacy. So this statistic is used to examine the appropriateness of factor analysis based on the sample of the study. So from this KMO measure of sampling adequacy, right, telling us whether the sample that we take is enough or not for the EFA analysis. How? By looking at the statistic value. Here, if the statistic value show you 0.5 to 1, that indicates the inappropriateness of the factor analysis for the data in hand. But if let's say the low value of statistic below 0.5 indicates the inappropriateness of the factor analysis, meaning to say the sample is not enough for EFA. So from here, maybe one question will be asked, how many samples is enough for EFA? Many scholars have their own judgment, their own different answers with different judgment. So if you want, some people say that 300 and above. Some people say that 350 or 180, 185. Okay, they have their own judgment. Okay, I don't want to decide the number of the sample. Otherwise, in the future, you all will just pick up the amount that I mentioned later. So what I strongly advise to you is to identify the sample and to make sure that it is enough for the EFA is one, based on the judgment, okay, refer to the scholars, okay, do the reading on the scholars, okay. The second one, are you going to do the judgment based on the sample? Okay. The third one, check based on the KMO value here. If your KMO value is higher than 0.5, right? Higher than 0.5, meaning to say it is okay. It is enough for EFA. Next one, the Butler test of sphericity. Butler test of sphericity is a very important test statistic also. We use this one to examine the hypothesis that the variables are uncorrelated in the population. In other words, helping you to easy to understand, the population correlation matrix is an identity matrix. Okay, each variable correlates perfectly with itself with the coefficient correlation with R is 1, but does not correlate with other variables, that is R equals to 0. So through this Barker test of sphericity, assess whether the correlation matrix of observed variables is significant, different from an identity matrix, indicating whether the variables are suitable for the factor analysis. So the significant result indicates that the variables share common factors and can be analyzed using the factor analysis technique. So let's see. This slide telling you, okay, from this slide telling you now, the value less than 0.05, okay, the value less than 0.05 indicates what? Indicates that the data in hand do not produce an identity matrix. Please understand that if the significant value less than 0.05, meaning to say the data that you use in your factor analysis won't produce identity matrix. We don't want identity matrix because as we an identity matrix, the factor analysis is meaningless. So therefore, we have to make sure that the significant value less than 0.05, okay, means that there exists a significant relationship among the variables, all right? So if the p-value again from the Barker test of sphericity is lower than our chosen significant label, this one, because sometimes not all the time you choose your choice is a 0.05. Sometimes some of the researchers they will choose 0.1 or some of them will choose 0.01. So it really depends on the significance level that you choose. So as long as lower than your chosen significance level, then the data set is considered suitable for the data reduction technique. Next one that you know is communality. We have to understand that communality helping us, okay, to identify the amount of variance a variable shares with all other variables being considered. Small values indicate variables that do not fit well with the factor solution and should possibly be dropped from the analysis. And normally values less than 0.5, we remove them. But again, this one is based on the judgment, all right? So, but normally my practice is less than 0.5. Then I know that this is maybe something is wrong, so maybe it's good for me to take it out. So normally the value less than 0.5, we remove them, okay? Now, few more here. The first one is the percentage of variance. Percentage of variance actually telling you how much the percentage under the specific factors actually contribute to this research. Okay. In other words, it gives the percentage of the variance that can be attributed to each specific factors relative to the total variance in all the factors. Next, eigenvalue. When you do the factor analysis, okay, I think you will see and listen to this keyword, okay, eigenvalue. Eigenvalue represent the total variance explained by each factor. And we really need to check on the eigenvalue to make sure that the eigenvalue over the value of 1, more than 1. Okay, that's why I say factors having eigenvalue over 1 are selected for the study. Less than 1, what happened? Less than 1, if close to the 0, maybe there is the multi-collinearity. If less than negative eigenvalues, meaning to say something is wrong, yield condition. Okay, so this is eigenvalue. Later we see the output, the example. Script plots. Script plots the eigenvalues and factors numbers according to the extraction order. And this plot determines the optimal numbers of factors to be retained in the final solution. Now, ladies and gentlemen, let's see this one, the factor matrix and the factors loading. The one I share with you here on the right hand side here, this is a component matrix. And this component matrix actually in other words also means a factor matrix. And in this component matrix here, as you can see, okay, this one component, okay, under this component, there are 4 different groups here. 1, 2, 3, and 4. And this component matrix, factor matrix, we generate it after we run the factor analysis. All right. And from here, you can see how this scale development working. factor loading here, factor matrix here contains the factor loading. Okay, now this one, all the numbers here, these are all the factors loading. Okay, these are all the factors loading. So what is factor loading? Factor loadings are simple correlation between the variables and the factors. Factor loadings tell us how well the items represent the underlying factor. Okay, so that's why we can, in the SPSS, we also can arrange the factor loading from the high to the low. So as you can see under the component number 1 here, the highest one is item B4. Item B4 with the factor loading 0.880. The next one is B7, item B7 with the factor loading 0.876 until the last one here, this one, this one here, B15 with factor loading 0.456 and 455 and 476. Okay, now let's see the variables here. Variables, as I mentioned to you, this is one of the rotation method. You want to run the factor analysis, you need to choose the rotation method. And normally, as I said, variables is the method, the most common method we use in factor analysis. So this method actually able to minimize the number of the variables that have high loadings of each factor. And this method simplifies the interpretation of the factors. Okay. Now, even though you don't use this direct obliquing DO, but you try to understand this one, huh? Okay. So I just want to highlight the difference between the parameters and the direct obliquing. Variance here, we use it for uncorrelated factors, okay? And then the obliquing here, DO here, is used for correlated factors, all right? Next method refer to the quantimax, okay? Quantimax. By using this quantimax rotation here, often a huge number of variables are included in the first rotated factor, and hence usually this method cannot be helpful in many kinds of research. Even though people try to run this, okay, one you can see here, this one. More generally, varimax focus on factors, and quantimax rotation concentrate on variables. You can do the quantimax rotation, but from my experience, it is very hard to interpret by using this rotation method. So that's why most commonly we encourage people to use varimax as it is easier for you to explain. All right. Next one is the equalmax. Equalmax here and the promax. Okay, these are another two rotation method. Equalmax a rotation method that is a combination of the varimax method, simplify the factors, and the quantimax method, which simplifies the variables. The number of variables that load highly on the factor and the number of factors needed to explain the variable are minimized. Okay, for the promax allow the factors to be correlated. The rotation can be calculated more quickly. Okay, it is useful for large data set, but again, for me, my experience again, hard to write the interpretation. Okay, now, so we already understand all the terms here. So now we try to deliver to you. I try to deliver to you to let you know that this is the process you want to conduct the factor analysis. So after the webinar, maybe you can take your initiative and see whether you can take a try or not. Huh? All right. The step number 1 here is about the problem formulation. The second one is the EFA requirement and so on. I will try to describe every step. Okay. So for the step number 1 here, problem formulation. Okay, problem formulation, this is the very first step. Okay, we all know that we want to conduct the factor analysis. The focus is we want to reduce the data. Okay, we want to reduce the data. So for this purpose, researcher, you must select a list of variables. Okay, and that will be converted into the new sets of factors based on the common essence present in each of the variables. So for selecting the variables, researchers can take the help of literature. As I mentioned to you just now, you want to find the groups of the entities that are able to measure the dimensions or the construct. You really need to read more through the literature review, the past research, or you use the experience of other researchers, okay, helping you to identify the good items that are able to represent it. And then the variable should be measurable on an interval scale or a rational scale. And another important aspect here, this one I try to answer this one. The factor analysis is to determine the sample size, which will be used for the factor analysis. As the time grows, the sample size should be 4 or 5 times of the variable included in the factor analysis. Okay, so it really depends on how many variables, and this is again based on the judgment. Okay, uh, sometimes I ask the students to collect one time in their pilot study. Okay, let's say for example they collect around 300 to 400. Okay, for the pilot study, and then for the factor analysis purpose, because of your scale involve a lot of different constructs. Okay, a lot of different variables. So you just think of these 4 or 5 times of the variable included, and then from the group of samples you collected, you can divide it into 2 different groups. So let's say, for example, out of 300, you can take 150 for the EFA, then another 150 for your CFA. Okay. Now, the second step here is EFA requirement. Okay, EFA requirement. So for this EFA requirement, okay, just now we see that if there is no correlation among the variables, if no correlation or if the degree of the correlation among the variable is very low, then the appropriateness of the factor analysis will be under serious doubt. Okay, cannot too low the correlation, and also cannot too high the correlation. You need to make the judgment. Okay, and then the Buckler test also we need to consider, as I mentioned to you before this. We need to make sure that we don't want the identity matrix. Okay, the existence of the identity matrix put the correctness of the pattern analysis under the suspicion. P-values less than 0.05, that the population correlation matrix is not an identity matrix. Okay, now in other words here, okay, as I said to you, the Buckler test of sphericity is an identity correlation matrix, means your variables are unrelated and not ideal for the factor analysis. That's why you need to make sure during the sample collection, okay, you need to follow the proper way, okay. Uh, so the commonalities, another one, the last one, describe the amount of the data of the variance, okay. The relatively small value of the commonality suggests that the concerned variable is a misfit for the factor solution and should be dropped out from the factor analysis. Okay. Now, step number 3, we need to select the appropriate factor technique. In your factor analysis dialog box, you will see this one, the principal component method. So the principal component method, normally people use this one. Okay, so for your first try, maybe you can think to use this one also. So when the objective of the factor analysis is to summarize the information in the largest set of variables into the fewer factors, the principal component analysis is used. Meaning to say, okay, meaning to say, in other words, when I say about the PCA, principal component analysis, this one actually refers to the dimensionality reduction method that is often used to reduce the dimensionality of large data set by transforming a large set of variables into the smaller one that still contains most of the information in the large set. And from here, through this PCA, okay, what means to say when we apply this method, okay, helping us actually to determine the minimum number of the factor that attribute the maximum variance in the data. So again, these obtained vectors are often referred to as the principal components. All right. Now, uh, principal component methods. Then the next one is a decision regarding the number of the factors. You, from a set of data, when you move into the factor analysis, then how many factors you want to get? This is another question. Okay. Uh, we as the researcher, especially the doctorate student, you as the researcher, you should be able to predict. Okay, I don't say to determine, I say to predict predict how many factors that you are going to to get from this set of data. So one way, if using the factor analysis, one way is we can get it through the eigenvalue. Because the eigenvalue here, it refers to the amount of the variance in the variable taken for the study that is associated with the factor. And these eigenvalues actually helping us to measure the amount of the variance accounted for by a factor. So it is very useful in determining the number of the factor that we need to extract. The only thing is you need to understand how to choose it. So if the eigenvalues are very low means what? Less than 1. If the eigenvalue less than 1, then there is little to no variance in the matrix, meaning there are the chances of high collinearity in the data. Then we don't want it. If the eigenvalues is greater than 1, then you should consider that this is the factor. And if the eigenvalue is less than 1, we should not consider that as a factor. All right. So this is how we choose. We can identify the number of the factors based on the eigenvalue. And sometimes if you cannot do this, you also can refer to the script plot. This is the script plot, okay? The plot of the eigenvalues and the component of the factor number according to the order of the extraction, okay? So from this plot, you can see y-axis and the other one, the horizontal line, the x-axis. Y-axis here, okay, this one refer to the eigenvalues, and then the x-axis, the number of the factors. As you can see, okay, this one, eigenvalues here, and eigenvalues, what we want is greater than 1. Greater than 1, okay, now we focus on this line. This line here, whatever above the line is bigger than 1. And then a cutoff of an eigenvalue less greater or equal to 1 will give you 4 factors here. How do I know? You see this one? This is the first one. This is the second one. This is the third one. And this is the number 4. So from this script plot also tell us that I'm going to have the 4 different factors. Now, script plots here, okay, script plots here, as I mentioned to you, is used to determine the optimal number of factors to be retained in the final solution. The objective of using this script plot is to visually isolate an elbow which can be defined as a point where the eigenvalues form a linear descending trend. Okay, and percentage of variance criteria, this one I think I briefed you just now. Okay, give the percentage of the variance that can be attributed to each specific factors relative to the total variance in all the factors. And this approach is based on the concept of cumulative percentage of variance. And the number of factors should be included in the model for which the cumulative percentage of variance reach a satisfactory level. And how to identify whether it's reached the satisfactory factor level. Okay, ladies and gentlemen, you can see on this one. Okay, the factors, if able to explain 60 to 70% of the variance, they should be retained in this model. Okay, how to get this 60% to 70%? Okay, later I show you one example. Now, step 5, factor rotation. After the selection of factors, the immediate step is to rotate the factor. The rotated simple structure solutions are often easy to interpret, where the originality unextracted unrotated factors are often difficult to interpret. A rotation is required because the original factor model may be mathematically correct but may be difficult in terms of interpretation. So if various factors have a high loading on the same barrier, then interpretation will be extremely difficult. That's why later I will show you if what happens if the factor with a lot of the variables with the same height loading, what should we do? Okay. So the rotation solve these kinds of interpretation difficulty. Okay. Now, model fits or not, this is in the step number 6, which is the last step of in the factor analysis to determine the fitness of the factor analysis model. In the factor analysis, the factors are generated based on the observed correlation between the variables, and the degrees of the correlation between the variables can be reproduced. For an appropriate factor analysis solution, the difference between the reproduced and the observed correlation should be small, okay, less than 0.05. So meaning to say a good model with the good fit will have less than 50% of the non-redundant residual with absolute values that are greater than 0.05. Okay, now I try to show you in this step number 7 after we run the factor analysis. So this is a step number 1. Click on the analyze and then we choose the dimension reduction, and then we choose the factor. So what I'm doing is I try to move all the 25 items into the factor analysis and let the SPSS using the factor analysis helping me to group and then to identify the number of the factors. Now, after I'm moving all in here, from here to this one, to the variable boss, okay, now I need to focus now on this, okay. So click on the descriptive button, okay, showing you the statistic, okay, measure, we click on this initial solution, okay. For the correlation matrix here, don't forget to take the coefficient. And sometimes if you want to take on this significance level, no problem. Determinant also no problem. But this one, very important. KMO and Buckler test of sphericity. Then continue. So when we come to this one, the extraction method, as I say just now, there are a lot of methods here. So up to you. You want to choose this one, the principal component or principal axis factoring, up to you. Okay. And normally we choose this time principal component and principal axis factoring. Okay. And then also don't forget, choose the script block because we want to see daily or not the answer. And select whether we want to analyze the correlation matrix. So if you want to measure on this one, the correlation matrix, select it, or covariance matrix. And don't forget to take on unrotated factor solution, script plot, eigenvalue, measure this one, and choose number 1. But by default, it is number 1. And sometimes I notice some of the researchers that take on this one, they decide the factors to extract. Okay, but make sure how to say support by the statistic. Okay, now what is the difference between the correlation matrix and this one covariance matrix? Okay, correlation matrix is a statistical technique used to evaluate the relationship between the two variables in a data set. The matrix is a table in which every cell contains a correlation coefficient, where number 1 is considered a strong correlation and 0 is a neutral relationship and -1 is no strong relationship. Okay, so this is the correlation matrix, but normally we choose correlation matrix. And then the next one is, okay, we come back to the main dialog box here, and then we want to decide the rotation method. So as I say, Perimex the common one, and don't forget to tick on this rotated solution, loading blocks. Okay, then we click on we continue on that. Okay, so Perimex rotation is applied since it can maximize the amount of the variance loading required for the factor matrix and provide a clearer factor separation. Okay, and Perimex rotation is with the assumption that there are no intercorrelation between the components. Okay, so Perimex rotation require larger set, normally more around 150, but again, Perimex still the common one. All right, now finally we click on the button label option. Okay, for the options here, there are 2 things under the missing values here. One is exclude the cases listwise, the other one is exclude the cases pairwise. But you have to understand the difference between these two. The first one here is this analysis is only run on the cases which have a complete set of data. If you click on the cases listwise, if you click on the cases pairwise, meaning we only focus on the cases that contain some missing data. Okay, so that is the difference. So it is advisable to suppress the values below 0.40, as this is a standard criterion used by the researchers to identify important factor loading. So normally some people choose 0.40, and I also notice some people choose 0.33 also can. Okay, so as long as you have your own judgment. So this is on the right hand side. This is the output from the factor analysis regarding the commonalities. So as I say to you, small values indicate variables that do not fit well. And normally values less than 0.5, we remove them. But you can see from here after the extraction, 0.6 from the B1 until the end here, all more than all more than 0.50, and this is good. Okay, the items is good to be used in this factor analysis. Okay, so we remain it. And then here, this one, the KMO. The KMO result here, as you can see, this one is a 0.922. We mentioned just now, KMO, what we want is more than 0.5. If below 0.5 with the low value of steady state, it shows that or indicates the inappropriateness of the factor analysis. In other words, meaning your sample is not enough for EFA. Okay, so if you get 0.922, then it is better, meaning to say the samples is enough for your EFA purpose. All right, and the next one here is, okay, this one is the rotator component matrix. So normally the items with loading factors value equals or exceed 0.55 have been accepted and maintained in their respective construct, since they have practically significant and have a good level of acceptability. Less than 0.55 automatically will be dropped. Okay, and this one automatically will rearrange by the factor analysis in your output. Okay, so I pick up one example here. As you can see, after considering the appropriateness of the type of analysis and sample size, the recommendation of hair 2010 and 2014 is picked up. And the loading factors value for the study is according to the appropriateness of the sample size. For example, my study now, my study involved total number of sample is 141. And these 141s, right, near to 150. So in this case, I have decided to use the sufficient factor loading 0.45. Meaning to say now, I need to check here and to check on this one, the rotated component matrix. All the factor loadings less than 0.45 will be disqualified. Okay, you see, so this one under the component 2.350, this one 380, 398, 383, okay, and all these less than 0.45, so will be disqualified. Okay, now, but one thing happening is you can see from here, uh, any item did not belong or even loaded into any factor was dropped, while the item identified as belonging to more than one factor will also drop. If one item located in two different components, we also need to drop them. Okay, for example, B2. Item P2, you can see part in the component 1 and component 2, same to item B4, item B10, item B14, B25, and B19, B18. But you need to be very careful, okay? You need to be very careful because you cannot just delete whatever you like, okay? So for example, this one, the items as belonging to more than one factors here, we need to drop them. Yes, definitely this one, B2, we will drop them. Okay, B4 drop, B10 drop, B14, B25 drop. But this one, you have to be very careful because B19 and B18, this one part in component number 4. Under component number 4, you don't see any more items here. That's why we need to make some judgment. Okay, later on I show to you. Okay, check the total variance. Explain for the construct. 4 components here, okay? The first component, then we have to measure the component here bigger than 1.0 because of computing the eigenvalue. You see the eigenvalue, this one, this is 12.2, that is good. 3.34 is good. 1.843, more than 1. 1.07 still bigger than 1. So meaning to say, we are going to have 4 different components here. 4 different components here. In other words, the first component here contribute 48.8%. Okay. And then the second component here contribute 13.36%, and the third one 7.4, and the last one 4.3%. And all together, the total variance here explained is 73.82%. And this is acceptable because it exists the minimum requirement of 60%, as we mentioned just now. Total variance contribute to the your research should be 60 to 70 at least. Okay, and this one already more than 70, and it's good enough. Okay, now, so come back to this one. Just now I do mention to you, I said that we have to make some judgments, right? Okay, see on this one, the B2 item, item B4, item B10, item B14, item B25, and B19 and B18. This one, we call them cross-loading item, because higher loading factors on 2 or more factors. Okay, so in this case, the researchers need to decide whether the cross-loading item should be dropped from the analysis, which may be a good choice if there are several adequate to strong loaders 0.50 or better. So if there are several cross-loader, the item may be poorly written or the primary factor structure could be flawed. So at last, we decide to remain the fourth component, okay, to remain B19 and B18 to the fourth component. Because why? My first judgment is this one more than 0.5, and then the second judgment, if I delete this one, then no more item to measure the component number 4. And the third judgment is, as you can see here, as you can see from here, the component number 4 do contribute at least 4.3% the variance. So that's why no matter how, I think it's good for me to maintain, to remain the item B18 and B19. Okay, so after we have done the factor analysis, okay, those drop items, we disqualify them. With those remain, we take it out, and then we rearrange it, and we use it for the interpretation and reporting. So when you come to the final step 8 here, we have to check the reliability using the Cronbach alpha. So the component 1, just now the factor number 1 here, after we check the Cronbach alpha 0.933, that is very good. Component 2, 6 items with 0.905. Component number 3, 5 items with 930. Component 4, even though with 2 items only, but still contribute to 0.743 reliability index. That is still good enough. All right. Now, so we come to, now it's already 1 hour. Huh? So we come to the end of the presentation. So I have my advice for you all. For the beginners in EFA, ladies and gentlemen, don't stress. The most important things at this stage is to master the knowledge of the terminology in EFA and understand the implementation of procedures. Then you can proceed to explore step by step to carry out the EFA. And to the participants currently enrolled in any doctoral programs, especially those focusing on quantitative approaches, it is encouraged to explore EFA and possibly complementary factor analysis in the future. And this is because we don't want not only to rely on the existing scale, but also aims to refine, to revise the scales according to the suitability of each study. Okay. So finally, I'm not the full-time statistic expert, as you can see from this slide. Okay. But I really enjoy within this 1 hour. I have I have my own time here and using my slide to share a lot of the knowledge with you all, and for those who truly need the skills and knowledge like this. Okay, and hopefully these evening sharings can benefit all of you. So if there are any mistakes, I really apologize on this, and do keep in touch with me. So again, I'm Dr. Ling Inle from Polytechnic Malaysia. So this is my email, drlinginle@gmail.com. So feel free to keep in touch with me. So I think that's all for my sharing. So pass it back to moderator. Thank you so much.
Now the session is open for Q&A. Is there any questions from the participant side? You may ask now. Is there any questions from the participant side? I hope there is no more questions from the participant side. So let's wind up the session. Thank you, Doctor. That was a thought-provoking talk. Thank you for imparting your knowledge and remarks on the concepts. Thank you once again, Doctor.
You're welcome.
Doctor, there is a question from the participant side.